So when we look at these two graphs, we can tell that algebraically they are the same. If you take the 1/2 outside of the brackets by squaring it, you will get 1/4x squared. So we're familiar with the fact that a is equal to a quarter. And this means that there's a vertical compression because its value is between 0 to 1. Meanwhile, when you look at it with the value being inside of that function, then k is equal to a half. And that refers to you having either a horizontal compression or a stretch. What that means is that you can look at it in two different ways. You can kind of look at the y value and how that is changing, or how the x value is changing. So let's go for a sec. So this green graph is y equals x squared, the parent graph. And when you look at what is occurring vertically there is a vertical compression because vertically you are thinking of it as if you're doing it this way. You're not vertically stretching it so that the graph is getting skinny. It's being vertically compressed so that the graph has become wider. That is one way to look at it. But you can also look at it horizontally. You can look at it horizontally as if you're horizontally stretching. So either way, depending on which way you're looking at it, the vertical compression and the horizontal stretch is very, very similar. It depends on how you're looking at it. So let's look at the values itself. The 1, 1, the 1, 1 are becoming two different coordinates depending on which way you're looking at it. When you are looking at the changes in y, the 1 is becoming a 0.25. Therefore, this number is becoming smaller. And when you're looking at it horizontally, this x value is changing and this value is becoming bigger. And so this is what I mean. Well, when we reflect at what the a value was and what the k value was, well, when we look at the a value was a quarter. So it kind of makes sense that you simply did 1 times 0.25 to get this new value, right? But when you look at the other value, k equals a half, well, how did my 1 of this x1 value become a 2? Because my k value was a half. So how do you go from a 1 to a 2? So it wasn't a simple multiplication. So when we go back here, down here, we have, okay, so the a value is a quarter. So for me to get my new y value, I must have done a times the y. So 1/4 times this 1, the y value of 1. And so therefore, I get 1/4. When I go over here, when I look at the horizontally stretched, k value is a half. Well, I definitely did not multiply 1 to k to get a 2. And so I reflect, how do I get a 2 from a half? Well, if I do x divided by k, if I do 1 divided by a half, I will get 2. So I should really have 1 divided by a half. That is the same thing as doing 1 times 2. So I should really have it the other way, but it's really the same thing. So when you do 1 times 2, that is equal to 2. And so what you can remember is that when you have an a value, you're going to do a times the y because it's the y value that is changing. When you're going to do a horizontal stretch or compression, you're going to do the x divided by k, and that's how you get your new value.